Hi there starts with the name of the Allah. Let's glimpse on the dairy cow feeding physiology part 2. In part 1 we discussed the digestive tract anatomy, human dynamics of a dairy cow and human fermentation of the carbohydrates. Today we will discuss regarding the metabolism of fats, protein, nitrogen, minerals and vitamins and milk urea nitrogen level indications. Protein and nitrogen metabolism. Protein are very important nutrient in the cow feed because the protein have a crucial role in cow growth, in cow reproduction and in cow production. As we know that protein break down into the peptides and peptides break down into the amino acids. And we also said that proteins are the building block of the amino acids. If we reverse this process, smaller amino acids made the peptides and peptides combine to make the protein. If we fed 100% protein in a ration to the cow, the 50 to 70% protein of that 100% consumed by the human microbes. Human microbes use that protein and against to this human microbes from the microbial protein. Protein break down in the human into the peptides, amino acid and in ammonia. Ammonia also used by the human microbes and by using the ammonia human microbes can form the microbial protein. MUN stands for milk urea nitrogen. The normal value of milk urea nitrogen varies from 10 to 15 mg per deciliter. But if the milk urea nitrogen value exceeds from the 15 or 16 mg per deciliter, there are two reasons behind this. First of all, there's too much production of the ammonia and the human papillae are unable to absorb that ammonia. The second one is that there is a normal production of the ammonia inside the human, but due to any reason human microbes are unable to utilize that ammonia for the microbial protein. And there are the three categories of the protein we will discuss in the upcoming slide. Proteins are further categorized into the three parts: soluble protein, human degradable protein and human undegradable protein. Human degradable protein and the soluble protein are utilized or used in the rumen of a cow, while the human undegradable protein passes as such the rumen of the cow and degraded in the true stomach, that is abomasum and small intestine, and absorbs in the small intestine. The examples of the soluble protein are urea and casein that are fermented inside the rumen. The second one is human degradable protein. Human degradable protein also further classified into the two groups: intermediate or the slow degradable protein or the instant degradable protein. Human undegradable protein, that is the third one, also called the escape protein and the bypass protein. Bound protein is a subtype of the undegradable protein. The protein which is undigested in the human, undigested in the abomasum and undigested in the small intestine, as such passes from the GIT of the animal to the outside in the form of the feces, called bound protein, heat damage protein or acid detergent fiber insoluble nitrogen. The normal concentration of the ammonia in the human fluid is 3 to 5 mg per deciliter. Here's the three types of protein that were discussed. Rapid human breakdown proteins, that are the soluble proteins, then intermediate and slow human breakdown proteins, that are the human degradable proteins. Further sub-categorized into the two classifications: intermediate rate of the human breakdown or the slow rate of the human breakdown. Third one is a human undegradable protein or the bypass protein or the escape protein. Bypass human breaks down in the small intestine or in the abomasum, but some of their part can't break down or digest in the abomasum or small intestine that is called the bound protein or the heat treated protein. Protein and nitrogen fate in the human reticulum depend upon the following factors like the solubility of the protein, resistance to the breakdown of the protein, and the rate of the feed passage. How much the feed passes in the human, that is very slowly or very fast. If the feed passage is normal or feed flows normal in the human, then there is enough time for the human microbes to work on that feed and they can digest that feed, or in according to this or in response to this they can form the microbial protein. But if the passage of the feed is too high or too fast, then there is a less time for the human microbes to work on that substrate or that protein, or ultimately there is a less production of the microbial protein. Non-protein nitrogenous sources, also called the NPN, and commercially they are the following examples of the NPN: urea, ammonium salts, nitrates, and other compounds. These NPN sources are also used as a source of a protein feed in a diet. Like the urea percentage is approximately 270, while the soybean meal crude protein percentage is 48%. Just like canola, crude protein percentage varies from 34 to 38%. And non-protein nitrogen sources are a chief source of the protein, but there is one drawback of the NPN sources. NPN sources can increase the blood urea nitrogen very high, as well as the milk urea nitrogen, and they have the very negative impact on the animal reproduction. Many commercial feed formulators or on the many commercial farms, urea used in the feed, but in a normal value like 1 to 2% of the version. Human undegradable protein digested and absorbed in the abomasum and small intestine, as discussed before. Abomasum is also called a true stomach, and we will discuss in the part 1 this some kind of digestion of the RPD also occurred in the abomasum. Here's a human, and what's done with the human or what's done with the protein inside the human is front of you. When we fed the protein to the animals or the NPN sources to the animals, that comes via mouth to esophagus, then inside the human. The NPN sources comes inside the human, breakdown into the converted into the ammonia. These ammonia used by the human microbes for their growth, and human microbes use that ammonia or convert this ammonia into the microbial protein, and this microbial protein passes from the human to the small intestine and absorbed in the small intestine in the form of the amino acids. Likewise, if we are feeding the true protein to the animals in the form of the natural ingredients like soybean, canola, rapeseed, these true protein break down in the NPN and peptides both. These peptides again break down into the amino acids, and these amino acids convert into the ammonia. Ultimately, the same cycle repeats again. Ammonia used by the microbial protein as a source of ammonia used by the microbes as a source of a microbial protein. This microbial protein absorbs in the small intestine in the form of the amino acids. The one important point, kindly keep in mind that every natural ingredient had also some portion of the NPN, like molasses, soybean, canola, rapeseed. They have the true protein source, but they have also minor or neglectable source of the NPN also. And there is a portion of the protein 35 to 40% that is called the human undegradable protein. Here is the example of the human soluble protein and the human degradable protein, while this is example of the human undegradable protein, human bypass protein, or human escape protein. Human microbes or human do not interfere with this protein, that is human undegradable protein. This protein passes as such from the human to the small intestine, and it's some part of this protein digested in the abomasum and some in the small intestine, and these protein absorbed as such in the small intestine and available to the animals, but in the form of the amino acids. And keep in the mind that the microbial protein and bypass protein sum is equal to the metabolizable protein. That is the combination of the microbial protein and the human bypass protein, also called the metabolizable protein. And if there is a excess ammonia production inside the rumen of the cow, this ammonia goes to the liver converts this ammonia in the urea, and where the salivary glands or where the other human other body fluids, urea again come in the GIT and again in the rumen, and inside the cow there is a recycling of the urea as well. Then now evaluating the MUN levels, milk urea nitrogen level. MUN levels, what's the indication behind this? The normal MUN level, as discussed before, is 10 to 16 milligram per deciliter. If there is low milk urea nitrogen, then there is one indication is that there is low ammonia production inside the cow body. If there is low ammonia, rumen microbes growth will astonish, or rumen microbes growth will stunt. Ultimately, there is less production of the microbial protein. But if there is high milk urea nitrogen, then the indication is that we are offering the cow too much protein according to their requirement or against their requirements. Then there is a wastage of the feed, and there is a wastage of the money, or there is a decrease in the profitability of a farmer. Always keep in the mind that never ever test a single cow milk urea nitrogen and predict any result. Must keep the 8 to 10 animals cow groups and then evaluating their milk urea nitrogen, then sum up their average and predict a result. Fat metabolism. Fat can include 2 to 3% in the ration of the animal, while we can also add the fat up to 6% in negative energy balance animals. There are following parameters that affects on the fat metabolism, fatty acid composition, inertness of the fats in the oils. Triglycerides are the type of the fat. Triglycerides made up of the 3 molecules of the fatty acids, while the 1 molecule of the glycerol. Free fatty acids is also a type of fat, or the smaller molecule, or the category. Free fatty acids is further divided into the saturated fatty acids and in the unsaturated fatty acids. Saturated fatty acids are better than the unsaturated fatty acids because the reason is behind that the unsaturated fatty acids stops or affect the bacteria that digest the fiber, or the unsaturated fatty acids made the layer around the fiber. Due to this, human microbes are unable to interact with the fiber or unable to ferment the fiber. Hydrogenation is a process that occurs inside the rumen in which the unsaturated fatty acids converted into the saturated fatty acids that are the good ones. By soybean meal, the fish meal have the proportion of the unsaturated fatty acids inside, and soybean meal and the fish meal have the negative impact on the process of the hydrogenation. Unsaturated fatty acids have the negative impact on fiber digesting bacteria and on the fiber as discussed below. And what are the limitations? How much we feed this ingredient per cow per day are mentioned here. Oilseed quantities, fish oil quantities, or animal fat. Animal fat we fed to the cow 454 gram to 80 gram per day because animal fat are good fat, or it contains the saturated fatty acids in high proportion. Just like that, the human inert fats are a good source of fat because the human nut fats are the coated fats that don't fermented or digest in the human. They are digested just like the bypass protein in the abomasum or in the small intestine, and they have the high proportion of the saturated fatty acids. But these fats are expensive, that's why are less used in the commercial version.